تم بدء التسجيل.
Assalamu alaikum. Welcome to the 7th lecture. Now, I think some of you might have a clash with another class, I believe. Some of the students sent me email saying like they have another class at this time. However, never mind, they can watch the recording of this lecture. Okay? Are you all with me? Can you all hear me? Yeah, okay. Right. So let's get started. Now, also I have to tell you that obviously you know your exam date. The exam, I think of CS140 will be on the 18th of November between 5 and 6. So please do make sure to study very well. Now the exam will include everything from the beginning, from lecture 1 to the end of this lecture, to lecture 7. Even if I don't get the chance to finish these slides, because they're quite few, quite a lot of them, I think they are in 40s. Even if we don't get a chance to finish them, you are required to study the rest of the slides in this chapter. So your exam will be from lecture 1 to lecture 7. Okay? Now I will talk to you about the exam maybe next week or the week after. I'll tell you the structure of the exam, how the exam might be and stuff. Anyway, just make sure you understand everything. Anything you do not understand, you have to work hard to understand it, and if you still don't understand it, make sure you ask your respective face-to-face tutor or email me with your question. Right, okay. So as from today, we will study the easier stuff. So alhamdulillah, we finished the big stuff or the difficult stuff. Now we're going to start with the little easy titles to study. So today I have a few things to present to you. Quite easy, but you have to understand them. Right. So we'll be talking about data in general. We'll talk about arithmetic. We'll talk about what else today? I can't remember now. Arithmetic. We'll talk about converting integer and double, and the final, how to have user input as well. Okay. So let's begin. So let's start with arithmetic operations. So we'll be talking about structured Java. How do we do arithmetic calculations? Now you know the general arithmetic operations are the plus, minus, the multiplication, and division. So let me get this out of the way. Something that annoys me. You cannot see it. I see it on my part. Okay, I'll stuff it there. Okay, yeah. So so we have addition, subtraction, multiplication, and division. Now, not something. Obviously, with the multiplication, we don't have the actual multiplication sign. Instead, we have the star. And for the division, also, we do not have this division. We actually have the forward slash. Now, if we are given this expression, a plus b divided by 2, what Java will do for us? It will add a and b and divide them by 2. Now, if we have this expression, okay, what will happen? Can you tell me what will happen if we just have a plus b divided by 2? What do you think will happen? Same? Yeah, it's actually b divided by 2, then plus a. I will explain about this very soon. This is something we call the precedence operation. We'll talk about it in the forthcoming slides. Right. Okay. So let's yeah. So also we have to know something that if we, for example, add two numbers. So if we say like excuse me, a تساوي 3 plus 3.4. What do you think? Obviously, so now we're adding, trying to find the value of a, but one value is integer and the other is double. What do you think the output will be if you have one integer and one double? What do you think the output will be? Will be double always. Okay, so if you have one value as integer and the other value as double, then the answer will be double. Similarly with the division. Okay, so if we're dividing double by double, you'll get a double. If you divide an integer by double, you get a double. If you divide in double by integer, you get a double. So in all cases, you will get this. 7 divided by 4. In all cases, you'll get the answer of a double. Right? Okay. I wanted to say something here, I think. Okay. So if you say, for example, integer x, okay, and you also have double y. If you want to add them, so you say z equals x plus y, okay, and you say z is integer, so you say integer z equals x plus y, you will get an error. You will get an error. It will not allow you, because it will say to you, hang on, you have one value which is a double, so you cannot have z as an integer. Okay, so turn the chart. Right. Okay. Now, now if we divide, so now we saw how we can divide two numbers of different type. Now, what if we divide like integer by integer? So if you have 7 divided by 7, what will the answer be? The answer will be integer, okay? And it will not round the number, so it will not make the answer be 2. No, it will give you the actual number. Think about it logically. How many 4 do you have in 7? How many 4 do you have in 7? It's only 1 4 in 7. So it will give you a logical answer, correct? You have 1 4 inside 7. So it will give you a whole number, which is 1. Now, what if you want to find the remainder, الباقي? Obviously, 7 divided by 3, sorry, 7 divided by 4 is 1, and the remainder is 3. الباقي 3. Now, how do we work out the remainder? Now, we have another special symbol for the remainder. It is the percentage sign. Okay, it is used for the remainder. And the remainder, the percentage sign, is called modulus, okay, or modulo, or mod. It is normally referred to as mod for short term, so we say 7 mod 4. So if you have 7 mod 4, it will give you the remainder. So 7 mod 4 will be 3. Now, what if I say to you 11? Now, you answer me for this one. What if I say 11 mod 2? What would the answer be? 11 mod 2. 1. Yes, correct. Because obviously 11, we have 5 2's in 11, will be 10. Okay, so we'll have a 10, but the remainder will be 1. Okay, so we do not care about the answer, the actual division. We care here about only the remainder. So if I say to you 11 divided by 2, the answer will be 10. Okay, in Java. But if I say to you 11 modulus 2, the answer will be 1. Okay, I think I have an example for this one, right? Okay, so if I say to you, if I have a variable called pennies, and I give it the value 1729, and I want you to work out how many dollars and how many cents is this. Now we know there are 100 cents in $1. Okay, 100 cents in $1. So if you want to work out how many dollars the 1729 will be, so we just say int dollar equals pennies divided by 100. It will give us the dollars. If we say on the other hand, pennies modulus or mod 100, it will give us the remainder only. It will give us 29. So we know now we have $17 and 29 cents. Okay? Is this understood? Is this understood? Do you understand this one? Do you understand? If you don't understand, obviously I will. You do not understand. No, okay, Mariam. Well, ask me at the end of the session. Why your question? Right. Okay. Let me turn the chat off. All right. Okay. Let's move on. Okay. Now, if you remember, remember the first question I asked you in the beginning of the lecture? Oops. Yeah. And I said to you, what will happen if we do not have a bracket? You know, the sentence was like this. Now, obviously, by the way, A plus B divided by 2 does not equal A plus B divided by 2. Divided by 2. They are different. Okay, so we need to find a way to work out this equation, or Java will find a way for us to work out this equation. If you put brackets, you have no problem. When you put brackets, you are telling the program, you are giving instruction to the program what to do first. So we have no problem. But in case we do not have brackets, there are rules to work this out. Now these are called the operator precedence rules. The operator precedence, الأولويات. Now always the multiplication, division, and the remainder have the priority over the normal addition or subtraction. So if we say this, if we put this in a family and say this is family number 1 and this is family number 2, okay, always family number 1 have the upper hand. They are stronger than family number 2. I do not mean that multiplication is stronger than division. No, they are the same. They are of the same family. But we always work from left to right. Now, if I give you an example, if I give you an algebra equation, can you see Z equals PR, blah, blah, blah. Now, note something. PR in algebra, PR means P times R. But in Java, we cannot have PR like this because it will be classed as a variable, right? So we need to spell it out. So we need to specify and say, like, okay, then we have P times R modulus 2 plus W divided by X minus Y. So what will Java, if you have this equation in Java, what will Java do? Now Java will follow the precedence order. Okay, so it will have the family number 1, which is stronger, but it will scan from left to right. So it will come say like, okay, then the first operation on the left is multiplication, which is strong. So we will do this first. Okay, so we will have P times R first. Then we will move along. We will have a modulus. So modulus also is from family number 1. So we'll have it as the second operation, right? And then we'll say, okay, then we have, after that we have plus. Now plus is the second family. So we have a division which is stronger. Division is stronger. So this will be dealt with next, right? Then we have plus and minus. Now plus and minus of the same family. So we will do the plus first, not because it's a plus, but because it's on the left-hand side, and then we will do the minus at last. Well, and then obviously we have the equality. Equality always comes last. Okay, but if we have, for example, if we have minus here and a plus here, obviously we will deal with the minus first because they are of the same family. Is this understood? The precedence? Is this understood? How do we deal with the precedence? Right? Okay, let me make things a little bit more complicated. Right, okay, just let me delete this if I can. Okay, let me delete these few things so you know, I can put my brackets. Okay. Now, if I put brackets, let's say, right. If I okay, I'll put. I'll just get rid of these. Get rid of these as well. This is annoying about writing and deleting. Never mind. So it would have been easier using a normal board, but never mind. Right. Okay. Now, if I put my brackets and say, let's say I put a bracket here, and then I'll put a bracket here. Okay, now you tell me, okay, I'm going to open the chat, just suggest a precedence for me. Suggest a precedence for me. First, obviously, yes, thank you. First will be obviously the bracket. First, no, it will be, no, not the division first, it will be the modulus first, because they are of the same family. Okay, so we will have the, sorry, we will have the modulus first. So obviously we're going to have to work inside the bracket, but even when you go inside the bracket, we're going to have to follow the precedence order, right? So inside the bracket, we have the modulus first from the left. See, now we ignored the multiplication. Although the multiplication comes first on the left, but because we have a bracket, we give the bracket a priority, right? So we're going to have to work with the modulus first, so this will come first, okay? Then the division will come next, okay, because they are of this family. I'll come next, and then eventually we will have the plus. See, although we have multiplication, which is stronger than the addition, the plus, but because the plus inside the bracket, it is given a priority over the multiplication. Once we finish this, we go back and we see our multiplication. We'll do it, we'll perform it. So we will multiply p by the output of this bracket. So after we work out this bracket and we get the answer, we will times it by t. Then eventually we will subtract y. Okay? Now, let me give you another example. What if we have a bracket inside a bracket? Okay? Now the question is, I'm going to open the chat for you. You tell me. Now, what if we have a bracket inside the bracket? What we will do? What will we do if we have a bracket inside a bracket? For example, like this. If we have this bracket, okay, and we have this bracket. And we have this, so something like that. What if we have like a bracket inside the bracket? What we do? Okay, find the answer from the inside. Yes, yeah, obviously. So if we have a bracket inside the bracket, we always work with the innermost bracket. Okay. So for example, let me write it on the right. If we have brackets like these, for example, we always work with the very inside bracket. Then we work with the outer one, then the outermost bracket, right? So in this example, the brackets that I've just shown you now, we will have to deal with the plus sign first. As I said, although we have modulus and we have multiplication and we have division, which are stronger, but because the brackets are given priority, and this is the innermost bracket, it is given even the highest priority. So we're gonna have to do this first, the one inside, number one first. Then we're gonna have, what do we do next? After we've done, you tell me. After we've done this addition, what we do next? Which operation we do next? After we've done the Q plus W, what do we do next? Yes, we do the modular, the mod. Yes, because it is of the same precedence as the. Obviously, we have modulus, we have mod, and we have division, and they are of the same family. But because the mod has come first on the left, so we have to deal with it first. So we do it, and then we do the division. Then obviously we go back and do the multiplication, and then eventually we do the subtraction. Is this understood? Is this understood? Yeah. Do you understand it? Excellent. Right. So let's continue. Let's move on. Right. We also have increment and just excuse me for a second. Okay, yeah, we have, for example, increment and we have decrement. We've come across in the past. Oh, by the way, I forgot to mention something important. Right, sorry. You know, this slide, the precedence rules are very important. I am sure you will get a question in the exam. Okay, so if you have not understood it, you've got to make sure you understand it, or ask me, because I think, I'm quite sure that I will bring you a question in the exam that talks about precedence. Okay, so I might give you an equation in the exam, or in any form, and ask you to find the precedence, or give you values, give you numbers, and you have to give me the answer. And as I said to you, if I give you numbers, if we have this equation, a plus b times c. Okay, like if you have a plus b, then times c, it does not equal. So b plus a plus b times c does not equal a plus b times c. So we have to be very careful in dealing with this scenario. So if I give you numbers, you're gonna have to work it out carefully and give me the answer. Or I might give you just give you variables, and you're gonna have to show me the precedence of them. So this slide is quite important. Now let's proceed. Now we have something called increment and decrement. Now I think we came across it during our previous lectures, but we haven't talked about it because we didn't really take it until this moment. If you have a variable a, for example, and you give a equals 4, okay, this has got a value, right? If you say a plus, it means you're incrementing a, so a will become 5. Now, if you have a while loop, we normally use the increment and decrement with the loops, which I will come to talk about loops in the next lecture. So if you have loop and you have increment in it, so for example, if you have a equals 4 and you have a loop, so you might end up a equals 10, because every time the loop will go, providing the loop is true, every time you will add 1. So the 4 will become 5, 6, 7, 8 until you tell it to stop. Right? On the other hand, we have a decrement. So if you say a minus, it means that a decrement. So 4 will become 3, 2, 1, so on until you tell it to stop. Now we'll talk about the increments more and decrements more when we come to talk about the loops. Right. Now let's talk about powers and roots. See, like in this is the 10th lecture. It's got like so many, excuse me, so many little titles. We'll talk about powers and roots, يعني الأسس والجذور. Right. In some programming languages, it's quite easy. If you want to say 3, if you want to say 3 to the power of 2, in some programming languages, it's easy. You just do 3, and then you give an arrow up, and you put 2, it will give you 3 to the power of 2. Now, this is not the case in Java. Java works quite different. The syntax for the powers in Java is math.pow with a capital M. It has to be exactly the same spelling as you see it in front of you now. So if we have 3 to the power of 2, in Java, you write it in this way. You write math with a capital M, math dot pow with a small. Between the brackets, you put 3, comma 2. This will give you the 3 to the power of 2. Now, this is a very silly question. What is the 3 to the power of 2? Very silly question. 3 to the power of 2. 9, yes, thank you. The reason I asked you, good, because I had students in the past where I asked them what is the value, what is the answer for 3 to the power of 2, they say 6. No, this is wrong, because when you say 3 to the power of 2, it doesn't mean 3 times 2. It means it means you times the number by itself. So 3 to the power of 2 means 3 times 3. If you say, excuse me, if you say 3 to the power of 5, means 3 times 3 times 3 times 3 times 3, 5 times. Okay, so well, I'm sure you know this. This is just I wanted to make sure that you understand this point. Okay, now if we have this expression, this algebra expression, b times 1 plus r to the r divided by 100 to the power of n. Now obviously in Java we cannot write it in this manner. In Java we have to spell it out as I said to you. So you're gonna have to write b. You're gonna have to write b star math.power, and then the expression inside the bracket has to be in this format. Now can you tell me now what we will do? How Java will solve this expression? How will Java solve this expression? What it will do? Bracket first. What exactly? Solve the power first? No, yeah, it will solve the division first, not the power. Not the power. It will solve the division first. So it will come. Okay, then we've got addition and we've got division. Who's got the highest precedence out of the two? Obviously, the division is stronger than the addition. So we will do this first. So it's going to do, Java will do r divided by 100. Once it's done that, it will add the 1 to it. Now after adding the 1, then we will do the power, because the power sits just outside the bracket. The power sits outside the bracket. So we finish the inside the bracket first, and then we will do the power. And obviously, eventually, we will finish up with the multiplication. Okay, I think it's written here somewhere. Yeah, here we go. So we have the division first, then the addition, then the power, the bracket, and then we add it to the we times it by the value of b. Right. Okay. Now, do you remember when I said to you? Now, if you have integer and double, the answer will become double. So I remind you, if I say a equals 4 plus 3.2, so we're having integer plus a double, the answer has to be a double, so it will be 7.2. Now, what if you actually want the answer to be integer? Now, if you say int a equals 4 plus 3.2, it will be an error. Java will not allow you to do this operation because it will say to you, hang on, a has to be a double because one of the operands is a double. Now, what if you actually want a to be an integer? Now you have to do something called conversion. You have to do something called conversion. Now we have two ways in doing conversion. The first one is called casting, which works like the following. If we have this example, I'll say to you, if you have a balance of type double, and you say integer double equals balance, it will be incorrect because the dollar is integer, the balance is the double. Now, what if you want to do balance to have balance as an integer? You have to do this little operation. Excuse me, my voice is gone. I've just had like a full lecture beforehand. Now you'll have integer dollar equals int balance, but you're gonna have to put the int between the brackets. It'll even in Java it'll color it for you as well because it's a reserved word. So you put in between the bracket integer, it will convert balance to integer. So if you have 7.2, what will it give you? If you have if the balance 7.2, what will it give you? 7. Yeah, it will give you 7. Unless you follow the other method, which is called even here if you have 3.8, okay, it will still give you 3. I know in mathematics 3.8. If we want to round it, we'll round it to 4. Okay, because anything 0.5 and above, it will go to the next number. Below 0.5, it will go to the number below. Now, but in this casting is different. Casting will give you the actual integer only. Now, if you want to round, if you want to actually do rounding, you're gonna have to use the other method of conversion. We use rounding technique. So you say, okay, then. For example, if you have you use math.run. So if you have, like example, like something like a method or something, or sorry, variable called round, you say, okay, long round equals math.round balance. Okay, sorry, this comes like this: long round. Okay, long round to convert for conversion. You say long round equals math.round with a capital M, and then you state the variable that you want to convert. Right. So if the balance is 13.75, as I think we so here, no, we didn't see here. Okay, 13.5. It will give you the answer 14. Okay, so you have two methods in converting the variable that you have. Now this is a couple of questions for you to read. I said to you, self-check questions. Might be important. I might well ask you in the exam. A couple of few questions for exactly from the self-check questions, just to test, just to make sure that you are actually aware of the slides that I publish for you. Right. Now this table summarizes what I've just been talking about. Apart from, I haven't talked about the square root. Now the square root, it's exactly the same idea as the power, the C power, but the syntax is different. Is math capital M dot sqrt square root, and then you have what's inside the bracket. Now have a look at this. Well, let me open a new page. Now have a look at this. It's giving you a squared plus b squared underneath the square root. Okay, so we have to write our math with capital M, our math dot square root. Okay, but then look, now you have, now we said the power, you're gonna have to use math dot po. Theoretically it should be like this. Theoretically you should write math dot po, okay, a comma 2. So you indicated a to the power of 2, but this is long to do it. So shorter form, this is just like a common sense. Shorter form, just say, okay, then it's easy. It's just a times a plus b times b. Very easy. Okay, so what will happen now? According to the precedence rules, the Java will work out for you the first multiplication, and then it's going to work for you the second multiplication because they have higher precedence. Then it's going to add them up together. Right? After it adds them up together, it's going to work out the square root. Now, this is because it's easy. Now, what if you have a to the power of 12? Now, obviously, it's impossible that you're going to write a times a times a times a 12 times. Now, you're going to have to use our math dot po. So you're going to say math with capital M, math dot square root. Then inside the bracket, you're going to put math dot po. Okay, a 12, and blah blah blah, whatever plus whatever, and then you finish stuff, because obviously it's impossible that you write a 12 times. Okay, so this is why I wanted to. Oops, no, I've written there. Okay, that's what I wanted to show you. Right? I think everything else is for the pi nisbة ثابتة, we have a syntax for it. It's math.pi. It will give you the nisbة ثابتة, and the rest just like as I explained to you. Right, I need to press on a little bit because we have quite a lot to cover in this lecture. Now this is a new topic as well. It's finals. We're going to talk about finals. Now, anything in Java, I want to talk to you briefly about it. Anything in Java that is declared, any variable in Java that is declared final, the value will never change. So if you declare final int a equals 5, okay, the value of a will always be 5 within the class. It will never change. even if someone wants to change the value of A or put it in a loop and do increment on it, you will get an error because the Java will say to you, hang on, you said A is a final, which means a final answer. Now, why this is important? This is quite important in some aspects. Now, for example, what if you're in a company and you're working out some arithmetic, I don't know, you work in a tax office, and you want the tax, which is A, for example, you want the tax to be 10% of the salary, for example. So you do not want anyone to mess with this 10%. So your colleague at work doesn't come and change the value. You don't want anyone to change the value because this is fixed. The tax is 10%. So then you use final. So no one can change the value of A. It is also important in some mathematical operations. For example, the pi, نسبة ثابتة. نسبة ثابتة is مسلمات. It's fixed. It's 3.14. This is fixed. So you don't want anyone to change the value of pi, then you can use final. So no one can change it. Now, you remember when I told you about using for the class name, using the first letter to be capital, for the variable, the first letter to be small. If you have two words, the second and the third word use the capital, capital as first letters, just to distinguish between the words. Now, this is, I'll say to you, this is not a disaster if you do otherwise, but it is a way of doing programming in Java. This is how people in Java program. Similarly, when they use a variable that is final, it is a good practice or a common practice to use all capital. Okay, so you use the whole word capital and you divide. If you have two words, for example, quarter value, there are two words. So how do you separate them? You separate them with underscore. This is, again, it's not a disaster. You can change it. It's only a variable, but it's a good common practice. This is how people program in Java. Anyway, right. So this is the final is the keyword to set a variable to be final within the class. Now, what if you want to transfer? If you want to transfer this variable into another class, like what we used to do before, when you open to objects and you transfer objects and transfer method, and you can change the value, and we have overriding, if you remember. Now, what if you still want this variable, you don't want it to change across the project, across all the other objects, you have to just obviously declare it public so it can be seen in the other classes. Then you say static final. Okay, and then you write whatever you want to write. Static final to stop it from being changed within other classes. Okay, right. Oops. Okay, this is the syntax. You can have a look. This is an example. Also, you can have a look at it and work it out as well. It's showing you the variables. The final variables, and they have been called from, this is a continuation, they have been called from another class. They have been called from the main class. Okay, so the values have not changed at all. You try it yourself and see, and try to change the values do the programming yourself. Try to change the values and see what you get. Okay, now, okay, a new topic again. We're gonna talk about user input. Now, so far, all the examples we had, it's like we didn't have a user input. We basically we had our values inputted inside the program, inside the main. Normally, inside the main method, we put our values. Now, what if we want the user to input values? Okay, this is quite interesting. Normally, students like this because you're allowing the user to enter values. Now, the user can enter values in this manner. Now, right, we have a function, we have a class in the library called scanner. Do you remember when I told you about the libraries? Okay, Java libraries. Java library has a massive amount of classes. Okay, so for example, if we have a scanner class, we do have a scanner class which allows the user input. You only need to call that class to your program. Right. Now, the method of calling, I'm trying to give you this good example. Obviously, the method of calling is the same method as we had before, right? Now, but the difference is, do you remember if you have, let me open a new page. I want to make sure this is clear for you. If you have a project, okay, in Java, in BlueJ, for example, and you have different classes, class 1, class 2, class 3, class 4, and then it's 1, 2, 3, 4, and then you want to call class 2 from class 3. So from class 3 you want to call class 2. And let's say this is called 2. So you use our magic word. You say you do 2 and you give it, for example, this is called A, for example, and this is B. Okay, what do? You say, okay, then A, okay, and you give it a variable name. Call it, for example, let me use a word. Let's say Java. Okay, let's say Java. Okay, you say Java A equals new Java. Is that right? And then you put your constructor. Is this right? Okay, to call to create an object for A and call the Java inside it. Okay, that's fine. You can do that because it's within your project. Now in the scanner, which allows the user input, in the scanner, now you cannot just simply do this. Okay, you cannot say scanner because the class called scanner, and you give it a variable name object. This is not a fixed one. It's the n is not input. Well, it is input, but this is something that you chose. But they chose in here because I said to you, normally try to use names that are meaningful. Okay, but to be honest, you can call this A, you can call it your name, whatever, right? It's a variable, but in here we used in, right? So we cannot come straight away and call this because why? Because we have not got scanner yet in our project. So you need to import this from the library to your project, right? So before you start your class, let's say you have a class Z, for example. Before you call class Z, before you create your class Z, before it you have to write this statement above. So you say import Java util, which utility. So Java import java.util utility.scanner. You are calling the class scanner from the library. Once you call it and it is here, now you can put this statement. You can put it in here. So you are calling this object. You are calling it inside your class Z to allow user input. Okay, this is an argument inside the class itself. Okay, as we talked before. Now, how do we prompt the user to input value? Is using this syntax. Okay, first of all, you're gonna have to tell the user. You're gonna have to tell the user that there's an input now. Okay, because if you don't, what will happen? You get a screen and you'll get a cursor, like this cursor that flashes. Okay, now if the user sees it, he might not necessarily know that there is a user input. Okay, so you're gonna have to let the user know that there is an input. Maybe put it in a form of a statement. Say system.out.println, please enter the number of bottles or whatever. You know, you just tell him, or enter the next number or something like that, so the user knows. Then you put the variable name, which is the bottle. This bottle you want to make it a variable, right? Which is a variable. Now, do you remember? And before I tell you this, so you have a variable, and then you prompt you allow the user. You have the in, which is this one. If this was A, this will be also A. Dot next integer. So you're in this state, in this method. This is a method. Obviously, you know the method. We called it from scanner. So in this way, you are allowing the user to enter to have a value input. Now, this is bottle here. Bottles is a variable. Now, do you remember what I told you about variables? We had a full lecture about variables. We said with the variable, we have to give a name, type, and a value. Okay? The name we have bottle, the type we have integer, and the value I said to you, you can either have a value straight away, for example, say int x equals 5, you're given a value to x straight away. Or have int x, right? Then later on you give x a value, okay, as we saw in different examples. Or the third way, as I said to you, I told you before, I told you, or the user can have the input. Okay, the user can have the input. So the user, the user puts the value. So the user here puts the value. Once the user puts the value, it will be stored inside the variable bottles. Okay, and so on. If it's double, you put it's double. If it's string, you put a string, and so on. Right. Let's continue. Okay, this is the syntax for it. I think we should have an example. Okay. Anyway, okay, I have quite a lot to do. Let's go through quickly. Now, also this is a new topic. We have something called formatted output. We know, you know, our print line statement or print statement. Now, if you put printf, you are formatting, يعني الشكلون الoutput. You are doing the output the way you want it. Okay. For example, if you are working out a number that comes out like this, okay, but you don't want the whole thing. You only want the first two decimals. So you want to have the 1.2. Obviously, it's going to be 2 because this will be rounded up because you have 5 here. Okay, so it will be 1.22. Now, if you want to have only that, it's easy. You put system.out.printf. F stands for formatted. F, the little f here, stands for formatted. Then inside a quotation mark, you put the percent sign, dot, for example, 2f, meaning I want 2 decimal places. Okay, this f is different from this f. This f is formatted. This is for the decimal. Okay, decimal means floating point. Floating point. Floating means double. Floating is it's used floating. For example, in C++ and C# and stuff like that, they call the decimals floating. In Java, we call them double, the same meaning. Okay, so 0.2 f means floating, so you're allowing 2 decimal places after the point. You're allowing 2 decimal places after the point. Then you put the price, which is the variable. Okay. Now you can format in different ways. If you put 10.2f price, it'll reserve 10 places for you. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it'll put the value of the last in the ones on the right. So if you have if you formatted the 3, it'll have 1, 2, I think 5, something like that. Okay, whatever, right? It'll have them from here, 1.215, for example, and so on. Okay. This is different ways of formatting. Okay, this is different way of formatting. Okay. Now, if you have different words, multiple words, so if you have like quantity and total, okay, 2 different variables, and you want to have 2 digits for the 2 digits, not floating. See, by the way, the formatted method has got different ways in play about with it. Okay, we will come across a lot of them through our study. So, percent f means floating point, which means doubles. %d means integer, full number. Okay, so if you want to have a full number here, so you say quantity space, for example, this is a variable, whatever you want to call it, space, okay, %d, it will give you, let's say the value of the d is 24, it will give you the writing because you've told it to show, you have the quotation, so it's going to say quantity, it will leave a space, which is here, okay, and then it'll give you the integer, which is 24. Then you left another space, which will be printed here. Then total, it will become here, right? And then you have another space here. It will, you have another space. It will be here. Sorry, not here. It will be here. Now you're saying, okay, then I want 10 places and put my 2 decimal. So it's gonna after the space you left, it's gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And it's gonna put you the whatever value you have. Let's say you have 17.29. Then you're gonna have to print the value of the quantity and the value of total. Is this understood? Is this understood? I hope it is. Okay, if it's not, just ask me afterwards. We'll practice a lot of these formatted. Okay. This is an example. This is what the example. This is, I think. Yeah, this is an input example. User input, and I think it's got some. Okay, this is actually a good example. It's combined both. Combined the scanner and combined the formatted output. So you can practice with this example. Okay. Self-check questions. You have to read them yourselves. Okay. Let's talk about strings. Strings. We know what strings is. We have come across dot length, meaning working out the length of the string. We have something called concatenation, which means like you're merging two strings. For example, if you have string 1, called its name, it's Harry, and you have the other one you called Morgan, and if you open another variable and say like s name plus l name, okay, it will give you Harry Morgan, but without space, because you have not specified spaces here. If you want the space, you can have 2, because we're dealing with strings. We always use the quotation marks because we're dealing with strings. So if you want to have a space, you're going to have to specify an empty space. Okay, so you can have Harry space Morgan, right? If you want to have like integer and string, so this string, this is integer, you can also do the same thing, but class it as string. Okay, so you say string, job title plus employee ID. Now this 7 will become a string inside here, right? Oops, what have I done? Right. Also, we can format. Okay, hasn't formatted it for us. Okay, no, the format, as I said to you, the print format for the string is %s. Okay, I don't know if it's written it here or not, but if it's not, I'm sure you'll have them in the future. Now, we have, you understand these. We're talking about them, a lot. Now, we've taken examples like these. So if you want to print out a total, for example, you can put total, or you can have a plus total. We've talked about this before, so I'm sure you understand these. What do we have here? This is the way you enter. This is the way you enter. So if you go back to our in, the variable that says in, you put dot next. Okay, dot next. It will allow you to type in a string. Okay, so this is the way you type string. Okay, talking about string and characters. Every string is a character. Character doesn't mean a string. Okay, but string is a character. Okay, character could be anything. Character could be a number, could be a space. Anything is a character, right? So if I say to you, 1, 2 space, 1, 2 space H. Okay, 1, 2 space H. How many characters is this? How many character? 4. Yes. 1, 2, 3, 4. Okay, so you understand this hopefully. Oops, have I done here? Right, more about strings and characters. Sorry, I'm skipping through this quickly because we run out of time, and I want to leave some space for question and answer. Also, these read them. They are quite some strings easy how to deal with each string separately. So now you can print, for example, you can print the first one, or you can print the second one. It's up to you depending on the syntax that you put in. Okay, so study this for yourselves. Okay, same idea here. It's quite easy, this one. It's just showing you how can we deal with the string and character, like as characters. This is an example as well regarding the strings. You can experiment with it yourselves. I don't think there's anything that is vague here. So I don't think there's anything that you will find difficult to understand, because all the syntax we just talked about them just now. And these are a couple of solved questions, or for you to read at home. Now this is the end of the lecture. Now I'm going to turn the chat off. Now if you have questions, please raise your hand. I think it's quite easy lecture. I know it's a long lecture, but if you do have questions, please raise your hand. There was a girl that wanted to ask a question as well. It's Munira here. Okay, Munira.
Yeah, Doctor. I don't understand the converting. Could you repeat it, please?
Yeah, conversion. Let's
Thank you.
Back. Conversion. Oops. Yeah, conversion. Okay, I said to you now. If you're adding or like doing like an operation between a double and an integer. Okay, one double, one integer. The result has to be a double. Similarly, if you're a double and a double, okay, also the result has to be a double, right? Now, what if you actually want the result to be integer? So you're having an integer and a double, but you want the result to be integer. Now you're going to have to do a conversion, right? So, for example, if you want to have 4, which is an integer, plus a double, 3.2, right? And you want a to be an integer. You don't want it to be a double. You're going to have to convert, right? You're going to have to use the syntax int before. So if you have a here, you're going to have to put int in between the bracket before a. So the result here will be 7. Okay? So if you say 4 plus 3.2, right? But what you do, you say like, okay, then hang on, I want dollar to equal int a, right? So the result will be 7, right? It will convert the double into integer. That's one method. Another method, you can do rounding. Another method, you can say long rounded syntax, long rounded equals math.round balance. Okay, or let's say a. We're talking about a. Okay, a. So it'll give you also, now it'll give you a rounding. Okay, so if you have long rounded equals math.round a, what it will do for you? In this example, we had 4 plus 3.2. So the result will be 7. Okay, because it's actually 7.2, but it's close to 7. What if we had? What if we had 4 plus 3.5? Now, the actual result will be 7.5. Okay, but we know in mathematics, in the rounding, now any value that is 5 and above, 0.5 and above, it will be rounded to the next number. So you will have 8 instead. Okay, so this is the conversion. Is this understood? Okay, hopefully yes. If not, then ask me again. All right, any other questions? Mona? Ask? Yeah, go on.
Hello, Doctor.
Hi.
I would like to ask you on slide 6, the rules of operator precedence.
This one?
Yeah, you said multiplication and division and remainder are one family. But if I did mod before division, is it okay? It's the same,
Yeah.
like.
Yeah. No.
There is no problem.
Yeah. I think what you mean is, well, depends on the question. But what you mean is, if we say, I'll give you an example now. I think you mean something like this. If you mean Z equals A mod B divided by C. Is this what you mean? Okay. So you've gone right. Okay. So I think what you mean is this, right? So obviously, yes, we're gonna have to add the remainder and the division of the same family. We cannot, in this example, we cannot do the division first because the remainder came first from the left, right? They have the same preceding rules, So because the remainder came first, so we're gonna have to do this first, A. Remainder B, we're going to get the answer. Then the answer, we divided by C. Okay, I hope this answers your question. Unless we do brackets. So if I say no, okay, then if I say A remainder B divided by C within the bracket, so now again, the bracket we give it higher precedence. So if there's a bracket, you're going to have to do the brackets first. So you do the brackets first. So you do this here, you get the answer here. Then you do the A remainder, whatever inside the bracket. Okay. Now if you have more than one bracket, okay, always again you do the bracket on the left first and then the right and so on. Okay, if you have a bracket inside the bracket, you do the bracket that is inside and then you go out and so on. Is this understood? I hope it is. Another question?
Yeah, but we
Yeah, go on.
sorry, but we have taught that the multiplication number 1 and division 2 and remainder 3 in order.
No. What did I say to you? I said to you, I do not mean the multiplication is stronger than the division. It's just like the way they put the multiplication, division, remainder. It does not mean if you have an equation and you have remainder, then division, then multiplication, you're gonna have to do the remainder first, the division next, second, and the multiplication third. Okay, I said there, which is why I emphasize this word. I said they are of the same family. Okay, they have the same strengths, the same family. I do not mean the multiplication is stronger than the division and the remainder. No. So if you see the division comes from the left, comes before the multiplication, you have to do it first. It's understood? Similarly with the plus and minus, I do not mean plus is stronger than the minus. If you have, let's go back. If you have 7 minus 2 plus 5, okay, you're going to have to do this first. You're going to have to do this first because the minus comes first, and then you do the next. Unless you have a bracket, same idea. Okay, unless you have a bracket. So if I say, okay, then these are inside the bracket, you're going to have to do this first. Okay, you get 7, and then you say, okay, then 7 minus 7. Oops, it's not working now. Okay, 7 minus 7. Is this understood? I hope it is. Okay, any other question? Any other question? Okay, so I hope this lecture was beneficial. There was someone who wanted who did not understand. I asked before. I asked if someone doesn't understand, and someone said no, he doesn't, or she doesn't understand. Anyway, never mind. If you do not understand, ask me now, or you can email me. Okay, or even speak to your face-to-face lecturer, which is why you have. This is a good opportunity for you to have face-to-face lecturers. You get the chance to meet them and ask them face-to-face. Okay, or you can always email me as well. Now again, the exam will be until today's lecture. Okay, next week we will have a lecture, but it will not be included in the mid-exam. So the exam will be from lecture 1 up to and including today's lecture. So today's lecture is also in the exam with us. So inshallah next week or the week after I will talk to you more about the exam. Okay, so that's it for now, and I hope you benefited from this lecture. Until I see you inshallah next time. So see you aman.
تم إيقاف التسجيل.